All right, we're moving right along here. We've done this and this and this. We spent forever doing this, and then we've got 2 more sessions. They're really good because we're going to be working with verifying trig identities again, and we are going to solve trigonometric equations. This is really good stuff. Here's our general strategy for proving an identity. We've been through this many times before. We're going to start with a more complicated expression when we're trying to prove an identity. Remember, we leave one side of the equation alone. It's fixed. And the other side of the equation is the one that we manipulate and change. And we keep going until the change is exactly equal to the other side. One thing we can do if we don't see any other way to go about it is to translate everything into sine and cosine. That can always be done. If you've got fractions, combine them over a common denominator. That will often show you the way. Remember that a difference of squares, and this comes up a lot, can be factored into conjugates. Be aware of where you're headed. If you're having a really hard time, try going from both sides and see if you can get to something common in the middle, and then you can use that to determine the full path. Well, let's try one here. I'll go through these fairly quickly. Let's see, verifying identities. Now in this case, we've got 2 sine squared 4 theta. Whew. Oh, but one of the things I notice, look at this. This one, 8 theta, equals 2 times 4 theta, right? So that's kind of a clue about what we might want to do here. So if I thought of this as double this, I could use this identity, couldn't I? The double angle identity, going from double angle to single. In this case, I'll be going from 8 to 4. That's going sort of, right? From double 4 theta, well, yeah. From double 4 theta to a single 4 theta. We can rearrange this by subtracting 1 from both sides. And now we have something that looks sort of like this. I mean, if I, what else could I do with this? I could say -1 positive cosine 2 theta equals -2 sine squared theta, which if I multiply both sides by -1, I get 1 minus cosine 2 theta equals 2 sine squared theta. Now the only thing I would have to go back and do here is consider that instead of saying 2 theta, I'm going to say 8. So it's going to be 1 minus cosine 8 theta equals 2 sine squared. And obviously, if this was the double, then the single is this. And I would have proved it, right? You like that? Now, we just worked, I actually didn't stick to only one side, did I? Yes, I did. No, I didn't. I didn't stick to only one side. What I did was see how to get to the answer. If I'm going to work with only one side, I will work with this side, and I will take it from being positive to being negative by saying I'm going to subtract times subtract, and that of course is the same as positive. And then I'm going to recognize that negative 2 sine squared theta is the same as this expression. And of course we've got this negative hanging around on the outside, and the very last thing I do is distribute this. So it may be helpful in verifying identities if you go off to the side for a few minutes and think about the relationships that you're seeing. All right, let's try this one. We know the Pythagorean identity right here, so that would make this secant squared. And what about this one? So let's look at the hint. What? My hint disappeared? That's not much of a hint. I guess I don't have a hint. Well, shame on me. That's a teaser. Sorry. Okay. So the first thing we had noticed when we looked at this was right here. Yes, we're working on this side of the equation. That was the same as secant squared theta. This is our Pythagorean identity. What's the next thing we see? Oh, that we could separate this into two fractions. Interesting, isn't it? Because one of the things we said right up front, oops, in our general strategy, right here, was combine fractions. And in this case and in others, we've seen that sometimes it's to our advantage to create separate fractions. So depending on what we're trying to do, we may actually go in the other direction. That's what we're doing this time. We're going from a single fraction and dividing it up. And that makes sense. We want to at least manipulate it and see what we can do with it. 1 over secant squared x. Ooh, well, we know what that is, don't we? And this is going to simplify in an interesting way, I think. Let's think about it. This one obviously was cosine squared x. And if we think about tangent squared, just let's separate these. Tangent squared x times 1 over secant squared x. And what is that equal to? Of course, cosine squared x. And we know that tangent squared x could be written as sine squared x over cosine squared x, and that's times cosine squared x. So that's where we get negative of this expression is the same as this. Now, how do I now say that I know that's equal? Because of my double angle identity, right? This is my favorite one for cosine. Cosine squared minus sine squared. Very good. Give myself 2 eyes. And one more. You can tell I like these, I guess, huh? So if I let tangent of a half angle be expressed this way, in other words, express it in terms of sine and cosine, let's see where we can go. Now I see a hint here, and I hardly dare look at it because of my previous experience. At least this time there was something underneath there. These are some of the identities that that do come into play here. All right, so we can see that we're going from a half angle to a full angle. So why not go from double angle to single angle? That amounts to the same thing, doesn't it? Let's work down through it. So we're starting off by, well, let's make it clear. We're working this side. And we're going to see if we can get this side to equal that. All right. So I'm expressing tangent in terms of sine and cosine. And I'm basically multiplying this by a fancy 1, right? 2 over 2. So why have I done that? Well, you can see down here why I've done that, right? I'm going to get rid of this. It's just getting in the way. You can see that I want to have this 2 in here. At least I think I do. Now, I'm going to multiply this whole thing again by another fancy 1. Why am I doing all of that? Because I've got my eye on this, remember? So keep your eye on the target and see if you can begin to approach it. So I did get to this expression as long as I think of theta as equaling half of x and 2 theta equaling x. So that will get me eventually, well, you can see it already, sine 2 theta. So we're going to end up with this expression here. Meanwhile, what can I do with the top? The numerator. I want to get to this expression here, which, so I can use this perhaps. Now let's think about how I could get there. If I want to have it look like this, 1 minus cosine x, then I would have to factor out a negative from each side, right? So I'd have a minus cosine 2 theta. On this side I'd have a minus 1 plus 2 sine squared theta. Alright, so I have the 2 sine squared theta, and I can head towards this negative 1 that I need in the front of this expression by converting my positive into a negative times a negative. And then I can have I'm going to want a positive 1 here. So if I add 1, then I have to simultaneously subtract 1. So put 1 here and then a negative 1 here. Now I have an expression which matches